So in this lesson, Chapter 3, Section 7, we're going to deal with graphing linear equalities. This is going to be something brand new in algebra, but it will follow some of the same patterns as you're used to on a number line, with just the plain old number equalities. So for instance, if you were graphing x is greater than 2, on a number line, because it can't be equal to, you would have had an open circle and you would shade everything above 2 or to the right. So we no longer use to the right or to the left, we use above and below. And if you were to graph y is less than or equal to 0 on a number line, you would have a closed circle at 0, and you would shade everything below 0, which just so happens to be the left on the number line. So we have those same patterns. We have a designation for the symbol greater than or equal to versus greater than. And we have a designation for the symbol less than or equal to versus less than, which would be on this number line an open or a closed circle. We don't use a number line for these, but we use these same principles. So if you look at the activity 3.7, graphing linear inequalities, number 1 on that activity says y is less than or equal to negative 4x minus 1. I hope this looks familiar to you because I hope you realize that looks an awful lot like the equation of a line. It's a linear relationship, and previously, before you had an inequality symbol in the middle of, or in between those things, you had an equal sign. And from the equation, if you were to look at this as something you're familiar with, it might say y equals negative 4x minus 1. And that is exactly where you start with these inequalities. So we're going to go to the y-intercept, which is a negative 1. And we're going to look at our slope relationship, which is negative 4. Well, if you look at negative 4 as a fraction, there's your rise over run. Just slap a 1 under it. So we end up from our y-intercept going down 4 and over 1. And there is the cutoff or the boundary of our inequality. So remember on the number line how you put a circle at the number where your cutoff was. This line is kind of like that circle. So where you put that circle on a number line was at the cutoff there, or your constant. Well, on the graph, the place where you start or stop, or your boundary or your cutoff, is the equation that matches your inequality. So basically I changed the inequality symbol to an equal sign and I graphed that. Now, from that, I need to look over and see, can this be equal to? And since my inequality symbol has a less than or equal to, it's a solid line. Now, if my inequality did not have the line underneath, and let's say, for example, I was graphing y is less than negative 4x minus 1, what I would do is make a dotted line. A dotted line is an open circle. A solid line is a closed circle. So in linear inequalities, if you have a less than or equal to or a greater than or equal to, that is a solid line. It's the same situation you would use a closed circle or a bracket if you learned your inequalities that way. Well, a less than or a greater than is a dotted or a dashed or a broken line, and that's when you would have used an open circle or a parenthesis on your number line when you learned that. Okay? So for this particular one, we have a solid line because it can be equal to. Now what you want to ask yourself is it less than or greater than? Well, it's less than, so that's everything below. Below or to the left. So because it's not an equation, it's not just the line. It's an inequality, so it's the line and everything below it. So that is everything under that line. And it just has a slight slant, and sometimes these are hard to tell. What I've always done for these that are almost straight up and down, and it's just visually difficult to see what is below the line, if you imagine that that line is a tree, a tree always falls down. Which way will this tree fall? Will it fall to the right or to the left? Clearly, this tree is going to fall to the left. And so that is going to be under or below. So if you're having a hard time distinguishing on your line what is below or above, imagine it was a tree. Trees always fall down, and the path of the tree will show you what is less than that line or below. So let's look at the answer choices. There is only one choice that has a solid line, and that is D. However, the y-intercept does match. It crosses at -1, and it is shaded below. If you will look at answer choice C, it's shaded above. That would be a greater than. And if you look at answer choice A, that has a broken line, so that would not have the equal sign under the inequality. So when you're graphing linear inequalities, the first thing you're going to do is graph the line. That is your boundary. Decide whether that line is broken or solid, and then you're going to shade on the correct side, either above or below, based on what your inequality says. So sometimes you're going to have lines in the wrong format. And when I say the wrong format, I mean they're not in slope-intercept form. For instance, number 21 looks like this. 2x minus y is less than or equal to 0. It can't graph that. I mean, you can, it's just hard. If you had something in this format, that's really easy to graph because your slope and your y-intercept is right there. So if you will do this just like you did when you had a linear equation in standard form and you were trying to graph it, solve for y, and then it's easy to see that boundary or that cutoff line. So we'll subtract 2x. Remember, x's are always pushy, so they'll push right in front of that constant. And then we don't want to know what y is. We don't want to know what negative y is. We don't want to isolate a negative y, so we're going to divide every piece by a -1. When you divide an inequality by a negative, you have to remember to flip your inequality symbol the opposite direction. So because I divided by -1, the inequality symbol will turn around. That is the hardest part of graphing inequalities, is to remember that. Well, here a -2 over -1 is +2, and the 0 doesn't mean anything unless you still need it to show yourself where the y-intercept is. And then if you just need it for a placeholder or reference, it's okay to write it there. Just know it will not show up in answer choices because we don't officially write a +0. So the y-intercept, remember when you're trying to graph one, really what you want to graph is your y equals 2x plus 0 to get your boundary line. Y-intercept is 0. Slope is +2. That's +2 over 1. So it's up 2 over 1. This will give you your boundary for this equation, and it helps you if you go all the way. Now, is it supposed to be a broken or a solid line? Well, since you have greater than or equal to, that means it's a solid line. Remember, if it had just been a greater than, you would have to dash this line. This one is not. It's the same as a closed circle or a bracket, so we have a solid line. Greater than is above, so we're going to shade everything above this line. And that's it. The first thing you need to do is get y by itself. It's so much easier to graph that way, and then look at the appropriate shading. So on number 21, the correct answer is going to be C, a solid line with a positive slope shaded above. Okay, good luck.